Hey class, in today's lesson we're going to talk about combinations of functions, which is found in section 1.4 part 1. We are going to add, subtract, multiply, and divide functions, and we're going to find compositions of one function with another function. So arithmetic combinations of functions. So just as two real numbers can be combined by the operations of addition, subtraction, multiplication, and division to form other real numbers, two functions can do the same. The domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. In the case of f of x divided by g of x, there is the further restriction that g of x cannot equal 0. And just as a reminder from what we've talked about in class, if I have f of x being divided by g of x, this g of x cannot equal 0 because that would mean that our function would be divided by 0, which makes this undefined. You cannot divide by 0. So with that being said, that's why we would have that further restriction with the domain. So how does it look? So the sum of f plus g of x would just be separated to f of x plus g of x. The difference, meaning f minus g of x, would be separated into f of x minus g of x. The product fg of x would be separated as f of x times g of x. And the quotient f divided by g of x, again, would be separated to become f of x divided by g of x, again, though, where the denominator, or g of x, does not equal 0. And again, because it would make it undefined. All right, so we're going to practice. So it says find f plus g of x for the functions f of x equals 2x plus 1 and g of x equals x squared plus 2x minus 1. Then evaluate the sum when x equals 2. Okay, just a reminder, they said, or I said on the last screen, that f plus g of x is the same thing as f of x plus g of x. So let's go ahead and substitute. F of x is here, so we have 2x plus 1, and we should technically use parentheses, plus the g of x, which is here, which is x squared plus 2x minus 1. Now this works for us because it's addition. In addition, you really don't need parentheses, but it's good practice because when we start using subtraction, you'll need to know that you'll have to distribute the negative. Either way, you should put it in standard form, which means highest power to lowest power. So f plus g of x should be x squared, so that's gone. And then I have two 2x's, so that makes that 4x. And then our 1's cancel because they are opposites. So f plus g of x equals x squared plus 4x. Okay, now that's the first part. Then the second part says to evaluate when the sum equals 2. So f plus g then of 2 would just be me substituting 2 inside. So that'd be 2 squared plus 4 times 2. Now 2 squared is 4, 4 times 2 is 8. Our answer is 12. So again, f plus g of 2 equals 12. All right, so with our second example, we're doing subtraction. So evaluate f minus g of x for the functions. It's the same function, so here we go. As a reminder, f minus g of x is the same thing as f of x minus g of x. That looks like a multiplication sign, but it's really subtraction. So when I start to substitute these two functions here, I will have 2x plus 1 minus, in parentheses, x squared plus 2x minus 1. Again, I mentioned you need to use parentheses so that you know that you distribute the negative to all terms rather than just the first. So it gives you 2x plus 1 minus x squared minus 2x and then plus 1. So that will then leave us with f minus g of x equal to, and let's focus on the like terms. That gives you negative x squared. That's the first one. Then we have the x's. So 2x and negative 2x will cancel. And then we have two positive ones. That makes that plus 2. So f minus g of x equals negative x squared plus 2. Then we will substitute in x equals 2. So f minus g of 2 then would be negative parentheses 2 squared plus 2. Now 2 squared you have to do first. 2 squared is 4, and then it's negative, so negative 4 plus 2 equals negative 2. So f minus g of 2 equals negative 2. In example 3, we are given the functions f of x equals x squared and g of x equals x minus 3, and we are asked to find the product of f and g. And by the way, after that, then we evaluate the function when x equals 4. So essentially, we're doing f g of x, which is f of x times g of x, okay? F of x is x squared, right? And then we're going to multiply that. I don't use the dots. I'm going to use parentheses. We're going to multiply that by x minus 3. Now, you can either use distributive property or you can use the box. In this case, I'll use distributive property. In other situations, my box would look like this. I would have had x squared on the side, and then at the top, I would have had an x and a negative 3. And then I would have put my answers in here and in here, okay? But anyways, x squared times x is x cubed, and then x squared times negative 3 is negative 3x squared. So f g of x is x cubed minus 3x squared. All right, then we're asked to evaluate the product when x equals 4. So that means f g of 4 equals 4 cubed minus 3 times 4 squared. So 4 cubed, I believe, is 64, but let me double check. Okay, I'm right, 64. Minus 3 times 4 squared, which is 16. 16 times 3, I believe, is pretty much what we just did with the 6. No, it's not. It's 48. That was going to be bad. 64 minus 48. And that gives us 16. So f g of 4 equals 16, and that's our second answer. All right, in example 4, we are asked to find f divided by g of x and g divided by f of x. And then for each of them, we're going to state the domain. So let's do the first one. F divided by g of x would give us the square root of x over the square root of 4 minus x squared. Now that's fine, but as far as our domain goes, first it's best to find the domain of each function separately. So the domain of f of x is from 0 to positive infinity. And then the domain for g of x, remember with this one, your goal is just to, well, you can graph it and you'll see it as well, but it is from negative 2 up to positive 2. Okay, so with that being said, our domain for the first function, and you can verify using a graphing calculator, your domain is from 0 up to 2, but it does not include 2. Okay? And then in the second function, if we set that up as g over f of x, we would get the square root of 4 minus x squared over the square root of x. And again, this domain will be from 0 up to 2, and it does include 2. So notice what they have in common and notice what they don't have in common. Essentially, their domains are the same except for the endpoints on each one. So just double check, look on your graphing calculator to see why, but I think visually you'll be able to see why once you take a look. All right, again, a very poorly warped image of the diagram that I'm trying to show you. But anyways, it says another way of combining two functions is to form the composition of one with the other. So the composition of the function f with g is f of g of x, which equals f of g of x. That's just the way you say it. And then the domain of f of g is a set of all x in the domain of g such that g of x is in the domain of f. I may have said that a little differently because I'm reading from my notes, but they're essentially the same. So this notation here means the exact same as this notation. This just uses parentheses, and this one uses that little symbol. It looks like a little tiny O, but it's f of g. That O means of. And I'm sorry I had to write this one, so it looks really sloppy, but it says find f of g of x for f of x equals the square root of x where x is greater than or equal to 0, and g of x where x is greater than or equal to 1. If possible, find f of g of 2 and find f of g of 0. So let's go ahead and start. So for the first one, if we want to try and find f of g of x, what that means is I take my g function and I put it into f. So my g function here, I'm going to put into my f function. So far my f function is the square root of x, but I'm not going to put x. I'm going to put x minus 1 because that is the g of x function. And then it says, and then we have to look at the restriction. So this restriction says, okay, well, x is greater than or equal to 0, and the other restriction says x is greater than or equal to 1. So our total restriction must satisfy both situations. So then our restriction overall is x is greater than or equal to 1 because it overlaps with x is greater than or equal to 0, but it starts at 1. Okay? Then it says, if possible, go ahead and find f of g of 2. So what we're going to do is we're going to take this function that we found, and then we're going to substitute in 2. So that becomes the square root of 2 minus 1, which is the square root of 1. And then just for the sake of doing a problem, rather than saying plus or minus 1, it is 1. And then the next one asks for us to find f of g of 0. So f of g, oh my goodness, I wrote that wrong. So f of g of 0 would be the square root of 0 minus 1, which would be the square root of negative 1. But this is not possible because we want to keep with real numbers, so we would say that this is not defined. And that is it. So if you guys have any questions, just let me know. Come see me for tutoring. Something else I want to mention on that last one, it says f of g of 0, and remember that as a combined restriction, we said that our restriction is only x values that are greater than or equal to 1. So 0 was also going to be undefined for that reason because 0 is less than 1, not greater than or equal to it. All right, so again, if you have any questions, come see me for tutoring.